unless you don't need to use it, and that will come in handy for adjusting the motion or speed of the monster relative to its size. And what else does a monster have? A monster needs access to the player to know whether or not there's been collisions. The monster will need access to the tiles for the map, so we'll pass that in by reference. And the monster has a type, monster type, type. Monster could be dead, and he'll probably have a certain amount of life unless he only can get hit once. And as with most animated creatures, you would have a position and a velocity. And for collision detection purposes, let's keep track of the old velocity, or the old position. And for showing him on the screen rather than having him only exist in world coordinates, we'll have a screen position. And where on the map is he? That'll need to be public too. His location, and his old location in case he tried to go somewhere he wasn't supposed to. And if he's jumping, you might need to know whether he's grounded or not, or if he's falling onto something. Oh yeah, we'll want to keep track of how we want his sound effects to be panned, based on where he is relative to the center of the screen. So let's start with a constructor, so we can generate a monster, taking in the position of the monster, access to meow motion, which all the monsters will share because they're all using the same animations, and we need access to quad bash so we can draw it. We need to know the monster's type. We need access to the map, access to what player's doing, where they are, and all that stuff. Let's get these things. Meow motion. We don't need the whole map, we just need the tiles. So we'll say tiles, map.tiles. Oh yeah, we'll need access to the bounce manager so that he can bounce. So we'll say bounce, we'll have to declare that. Right around here we'll say bounce manager by reference, bounce engineer. I'll just comment these. Kind of divided these up into sections. Got the animation stuff, map and player stuff, and stuff relating specifically to the monster, and sounds, which is only one thing. So now we can say bounce mgr is equal to map bounce manager, and we can get the player. We'll set the animation stuff and the map related stuff. Now we'll move on to monster stuff, monster type, and we'll go string sheet name. So it'll come in handy in a second here. Get monster properties based on type. So we got to create that method, and then we can use sheet name with the meow player we're going to create. So meow play is equal to a new meow player for this monster, using that sheet name, starting position, access to meow motion, and access to quad batch for drawing. Say position equals the position, and position is equal to position. Start off the screen position to be the screen coordinates, so world to screen position. The map coordinates, we'll just use converter again, get tile chord of position. Dead is false because we're creating a new one, and we'll want some customization for the monster, so we'll add one of those that customizes the animations like we did with player, and we'll set the current animation and such. But we'll do that after. Get monster properties will return sheet name. So string sheet name get monster properties given a monster type and type. Maybe by default we'll set sheet name is equal to say monster. And we'll add return sheet name. Now, obviously it might not be. So switch for the type, and this would be a monster type, M type. Switch, case monster type, monster, and case monster type dot hellcat. So here we'll set the sheet name. Name is monster. For this one, sheet name. You may need to check the file to make sure these are right, because you might have spelled it differently or used a capital letter or something. So it's going to use these to look up the monster in the dictionary using a fairly efficient hash table system. We'll set collision detection properties in here later for each monster, but this is all we need to do for now. In our monster constructor, we have this customized monster method that we'd like to make for customizing the animations for the monster. Let's go under get monster properties, and we'll set that up to void customize monster index, and we'll store the jump index and the ouch index. So let's put those up above first. We'll go to male animation. Actually, before we do that, let's add some motions, just like we did with the player class. We'll go up here and add in some actions. For example, act, idle, walk, run. One of them can walk, one of them can run, so based on which creature it is, it'll have to use one of those. We might have creatures that can do both walking and running, so we'll keep both of those. And I'm going to have some finite state machine stuff for the AI. So what mode is the monster in? Does he want to wander around? Does he want to run away? Or is he patrolling? We could also put an aggressive state in here too, like charging, so he just wants to attack you for some reason. So for animation selection stuff, we'll put motion and act, we'll put motion and last motion, so that we know whether or not we need to change the animation, and can make decisions based on what mode he's in, how the monster will act. We'll keep track of some of those indexes. So we'll have a walk index, and a jump index, and an ouch index. That way it can just set the animation based on the index right away. And oh yeah, we need to keep track of how long he's been doing a mode, so that he can switch between modes after a certain amount of time, and the total time that he should be in that mode. And just like with player, we'll have the option to must finish animation, which we'll do for ouch, so that you can see for sure the animation is triggered and you know for sure that the monster received damage. So if he gets hurt, I think we should do like we did with the player and make him invincible for a bit. That way if the monster falls onto spikes or something, it doesn't just die right away. So if that's all you had to do is trick it into going on spikes, it'd be very easy. Oh yeah, in the constructor we can get the rescale value too. So we'll just say rescale is equal to game1.rescale, and we can use that in setting up how fast he can go based on his size. Since we have our enumerations for animation, we can set a default motion to be act.idle, no, not idle, and we'll set a starting mode to be mode.wander. Back into customize monster again. We'll set the jump index, which will make things easier later. We'll get the index, and we don't need to show errors. Ouch index, get index for ouch. So just a note that only one of the monsters actually has a proper jump animation. The other one we're just going to have him come off the ground like he's jumping. So that's why I have this set to false. So one monster will load a jump, the other one won't, but whether or not he has an index for jump won't matter. He'll just leap off the ground. So this will return 0. The jump index will be the first animation, which is his idle, which will work fine for jump. Switch type. So for monster, let's set animation to idle, flip, set the motion to act.idle, and we can get the index to customize it. Play.getIndex for idle. And now that we have the index, we can say animation index and set the speed to 0.8f. Actually, we could have got the index and then just did this by index, but that's okay. And then we'll go walk index equals play get index. And this is where we're kind of fixing the problem between walk and run. This guy has a run, the other guy has a walk. For the other monster type, Hellcat, copy this. It's basically the same speed. Let's change this to walk. We could even take this out of here and just make it default, stick it up here, and then just have the switch work on the walk index or whatever other differences there are between the characters. In fact, let's actually do that. We'll just put this here. And if you run into a snag where that's not going to work, then you can just put these differences back in here or into your creatures and make the necessary changes. Just added a couple comments here. Okay, so we have something for creating a monster. If a monster dies, we might want to shorten the list, change who's where within that list. So we're going to need to be able to change a monster. We'll call it change monster, add a position, and the monster type that we want. Position equals position, so we'll set the old position to be that position also. And of course, just like we did above, screen position. Actually, we can just copy that code, copy some of this, and just put it here. And we'll say type is monster type. And kind of like we did here, sheet name, we'll go here and say sheet name is get monster properties type. So we got the proper sheet name, and then we're going to be playing the correct animations. And we'll have to do customize monster again. Set the default to act.idle. Although I think it does that in down here. Yeah, it does actually. So because customize monster does that automatically, we can actually take these two lines of code out. because it's a little redundant. I'm going to copy the hero jump out of player into monster, and we'll make a monster jump version. So we'll change hero to monster. We could use a stored input scheme for making demos, but we're not going to. There's other ways of doing that too anyway. Okay, they don't have various jump modes. They're fairly simple, so we can get rid of that part. And just say motion is already act.jump, and we can return. We're not doing any input checks. We'll say if not, keep motion. And the jump index actually exists, so we actually have an animation for jump. And we'll say motion equals act.jump. Let's get rid of this. And we'll say grounded is, we don't have that, so we can get rid of that. Grounded is false. Now, key may be left or right of the player, so we don't want to just play the sound normally, we want to pan it. So we'll use this pan value, which we'll have to update at some point. So pan.x is the actual panning. Pan.y is just the overall volume. And pitch, we could just leave it as 1. I made it a little bit lower. Otherwise, we're going to play the bounce sound because he hit one of the bouncers. Give it a slightly different pitch because it's a monster that hit it. We'll just say if must finish animation, and make sure that we set the jump velocity because otherwise it's not going to set it because it's waiting for the animation to finish. We'll head back over to monster sys and go to add monster class. So we're about to deal with damage, so let's make sure we have a way of taking care of dead monsters. So we'll go while I is less than the number of monsters. If monsters I is dead, and we'll say monsters I dot change monster position and type. So it's not just going to automatically add a monster every time a monster dies, but if we want to spawn a new monster in the scene, it'll check to see if there's already a dead one, and it'll just put the new monster in the index of the dead one, and then give it a new position and a new type. So somewhere off screen where it's going to spawn it. So now we have the option to spawn a new monster. Otherwise, we're creating a new monster. So let's make sure we don't go over a maximum limit. So if it's greater than or equal to max monsters, we'll just return and not create another new one because then we'll have too many. And we'll say monster plus. Okay, we'll go back over to monster.cs and we'll add in a damage. Actually, let's go to player and just kind of copy that. So we'll do this hero damaged, copy it, and go into monster, just after monster jump. We'll add it in, change this to monster damaged, certain amount of life loss. To make it a bit easier to tell that the monster is damaged, let's just set them that they jump into the air a little bit. Now, we'll do the male player set animation, ouch index, flip, and we'll set must finish animation to be true. We'll just go motion equals act.ouch because we have that indexed. Because we directly set the animation, so we got to make sure that we update this to match it. And the monster doesn't do any ducking, so there's no duck reduction of damage. The monster has life. We'll say life minus equals life loss because it doesn't have its own heads-up display. Oh, and our monsters are using integers for their life rather than float. Set invincible to 100, and then we got to play the correct sound. We can't just say sound.ouch.play unless all our monsters made the same sound. So we'll say switch type, case monster type. One other way we could do this is to just assign a sound when we create the monster based on what monster it is, but we'll just do it this way. It'll be fine. Monster ouch 1. Pan.y for the volume based on how far up and down he is, and the panning value for stereo panning based on his horizontal position. Do the same thing for Hellcat, except this will be ouch 2. Then we can go here, change this to life less than equal to 0. We'll just say 0, and we'll say dead equals true. We'll make an explosion. We'll use the explode class, or add or something like that. And we'll pan it, y, pan.x for horizontal panning. Oops, this should be .y. Okay, and he's not resetting his world position, so I think that's all we need for now. We'll just have to remember to add our explosion stuff here after. Go down a bit, and we'll add an update. Public void update. Game time, in case we need to use that. Boolean AI. True by default. When we're using our editor and we place monsters down, we don't want the AI updating, so we change that to false. Or we pass in false, I mean. So we'll make sure we store the old states. Location equals the current location. If update AI, and we'll update the AI. And we'll have to make an update AI. Just kind of separating these so it's easier to find your way around the code. Okay, I'm going into the update for player, and I'm just going to hijack some of that code. For gravity down to move player, and then go back into monster. And after update AI, paste it in here, and I'll just modify it. We can leave these values the same, and and we're just going to use his velocity to determine which way it's facing for this guy, or for these guys, because they're simple enough that we don't have to worry about them facing a different direction than the direction they're moving. Okay, we don't have the walk anim yet, so let's go, we'll just point to it, walk anim, using the walk index that we recorded. And this will be the same too, except we just take this out. And this will work a bit differently. Say if the velocity.x is less than -1, we'll just say flip is true, else if, because if velocity is 0, we don't want it to change directions, else if greater than 1, then flip is false. So if you had a monster that by default was facing the wrong way, you'd probably want to record a default facing, and then when you use these, you'd say either not default facing or default facing. In our sounds, we keep using pan, but we haven't actually set pan yet, so let's add stereo pan. Pan, sound, get pan, based on the screen position. And based on the motions, we can set all our animations with an update here. We'll need an allow switch, which is true at first. Must finish animation. If not, gameplay.is animation done. Is it done? If not done, allow switch is false. Otherwise, we can say we can turn off must finish animation and set the motion act.idle, and then idle will decide what to do. If we are allowing a switch and the motion isn't the last motion, then we can set our animation based on the switch for motion. Case act.idle, meow play, set animation as idle, flip, break. And then I can copy that. Walk, run, ouch, we'll say walk, run, tag. Oh yeah, and the one guy has jump, so I'll add that too. Jump, walk, run, tag, ouch. Jump's a little different scenario. We'll say the jump index is greater than 0. We'll set the animation jump. So if he can jump, animation actually exists. So it's possible that for some reason motion got changed to act.jump even for a monster that doesn't have jump. If it doesn't, the index would be 0 for it, and then it would just skip this. Apparently I can't spell switch. There we go. And just like with player, we need to set the meow motion player's flip value. Play.flip. And you're probably wondering, if we set the flip value here, what would be the point of setting the flip value again? Well, the thing is, this might not happen, and he might be facing a different direction now because the animation hasn't changed, so none of these have actually executed. So we got to make sure that it's flipped to the correct direction. And we also got to make sure that we don't keep setting the animation over and over and over again. So we'll say last motion is equal to the current motion, and then it'll only do this if the motion is different than it was before. So let's go up to above update so we can create this update AI thing. Say void update AI,